What is the cosine of an angle that has a cotangent of negative square root of 3 over 3? Now, the fact that this is inverse cotangent makes this question just a little bit tougher, but the cosine part we're just going to carry around till the very end. That's not going to make the problem any harder. But in the end, since this is an inverse question, we know that this in the middle should come out to be an angle. So that's how I know I shouldn't sketch a triangle. Sketching a triangle doesn't help me. This is a ratio from the unit circle. Now, I am probably least familiar with cotangent, but when cotangent of an angle is this, I know tangent is the reciprocal. So if I flip this over and rationalize and reduce, cotangent is negative square root of 3 over 3 when tangent is negative square root of 3. That's its reciprocal. So, of course, the long version is going to be thinking about which quadrant tangent is negative in, guessing and checking some of those points with sine divided by cosine. It's a whole lot quicker if you memorize the tangent values. They are square root of 3 near the y-axis and negative in quadrant 2 and 4. Now, one trap that's really easy to fall into is when I rearrange this from a cotangent equals to a tangent equals, it's tempting to say, okay, well, tangent is here and here, and tangent is from negative pi over 2 to positive pi over 2. The problem with that is, this isn't a problem for any of the other inverse trig functions, but for this one it is, because I don't care where there's an angle that has a tangent of this. I wrote it that way out of convenience. I really want to know where there's an angle that has a cotangent of that, which would be during those times. So you got to pay attention to what the question was asking. So it's right here at 2 pi over 3. So all the inside becomes 2 pi over 3 from that inverse problem. And then after that, this is what we've been doing since about week 2 of school. If you go to 2 pi over 3, cosine is the x value there, and the x value at 2 pi over 3 would be negative 1/2. So notice on the outside here, it was a regular trig function, so my answer ended up being a ratio. If the outside is an inverse function, like number 16, your answer should be an angle. So that gives you a little bit of guidance too about what your answer should look like. But again, this is definitely on the harder side. Are you okay with how I came up with the 2 pi over 3 in the middle?
Yeah.
Okay. But again, it is tricky. Anytime you change inverse cotangent to inverse tangent for convenience, make sure your answer is still in the range of inverse cotangent. It's very similar to what we do in the calculator. Like, if you remember, if you were to throw this in the calculator, your only way to do it would be to do inverse tangent of the reciprocal. And if it's inverse cotangent of something negative, that gives you an angle down here in quadrant 4. And to get it in quadrant 2, which is what you really want, you have to add pi. We're doing the same thing, it's just not calculator. So.